Hello students, this video lesson is about adding and subtracting fractions. When adding or subtracting fractions, we are determining how many of a certain type of part is present. In order to add or subtract the type of parts, the parts have to be the same size. The denominator of a fraction describes the size of the part. The numerator tells us how many of that part is present. In our first rectangle, we have 9 separate parts. 4 of them are selected, so we have the fraction 4/9. In the second rectangle, we have 9 fraction parts, with 2 of them being selected, so we have the fraction 2/9. When we add how many parts have been selected, we add the numerators. 4 plus 2 is 6. So 6 out of the 9 parts have been picked. Now 6 over 9 can be reduced. To reduce 6 over 9, we simply divide by a common factor that 6 and 9 share. And they both share the common factor of 3. So I divide 6 by 3 and 9 by 3, and I get 2/3. So 2/3 of the entire rectangle is been selected. It's being represented by the addition of these two fractions. To add or subtract the fractions, just add or subtract the numerators, the top number, and put the results over the type of part, which is the bottom number, the denominator. When negative and positive numbers are present, use the rules for adding integers when you add or subtract the numerators. So as a recap, the first thing when you add or subtract fractions, you have to rewrite over the common denominator. Then add or subtract the numerators, and then reduce if possible. So our first example is 1/4 plus 1/2. They have the same denominator, so I rewrite them over the common denominator. Then I add my numerators. Because 3 over 4, both 3 and 4 do not share a common factor, 3/4 cannot be reduced. My second example, they have a common denominator, so I rewrite it over the common denominator. -6 plus -2 over 13. The rules of adding integers, they have the same sign, so I just add them together and keep the sign. 6 plus 2 is 8, so my answer is -8 over 13. My third example, they have different signs. Again, I write it over the common denominator. When I add my integers, because they're different signs, I really subtract. I have more positives than I do negatives, so my answer is going to be a positive 1/9. Now my fourth example has a letter with it. A lowercase letter represents a value. They're called variables. They vary in their values because the value may change depending on the situation. But if they're the same letter, they're the same value. If they're different letters, they're going to be different values. So if I have an x in my denominator and they're both are x's, that means they have like denominators. And I can rewrite that over the common denominator. So I have 6 plus 11, which could become 6 plus -11. The rules of adding integers tells me since they're different signs, I subtract. I have more negatives, so my answer has to be negative. And in this case, -5 over x. My fifth example, I have a common denominator of 4 and 2 separate values on top, an x and a y. We don't know what value they are, but we know they're different. Because they're different letters, I can't add those. I just leave it like it is. And my last example, again, I have a common denominator, so I'm going to rewrite it over the common denominator. And since x is not a number, I can't really subtract 7 from it. So I just list it as it is. Okay, so now I'd like you to stop the video and give these 3 addition problems a try. And when you get done, check your answers. So how did you do? -1 plus 9 over 11 is going to give me 8/11. It doesn't reduce. 15 over x minus 12 over x is going to give me 3 over x. It doesn't reduce either. And my last one is x over 18 plus 5 over 18 equals x plus 5 over 18. That's all I can do with that. Let's move on. And subtracting fractions with different denominators. If two fractions are being added or subtracted and have different denominators, equivalent fractions with the same denominator must replace each fraction. Once the denominators are the same, add or subtract the numerators and place the result over the common denominator. There are different ways to find a common denominator. First, if the smaller denominator is a factor of the larger denominator, then the larger denominator is the common denominator. For example, in the problem below, the larger denominator is 22, and the smaller denominator is 11. 22 divided by 11 is 2, which has no remainder, so 22 is the common denominator. The first fraction does not need to change, but the second fraction needs to change so that the denominator is a 22. To create an equivalent fraction, I would multiply the numerator and denominator by 2. 11 times 2 is going to give me 22, but if I multiply it to the bottom, I also have to multiply it to the top. 5 times 2 is 10. So my new problem becomes negative 1 over 22 plus 10 over 22. It's a new but equivalent to the previous listed problem. Now that they have the same denominator, I could rewrite that over one denominator and add my 10 plus negative 1, or negative 1 plus 10, and I get a positive 9. They're different signs, so I really subtract. 9 over 22 does not reduce. Because they have no common factors. Now, there are other ways to determine a common denominator. Sometimes if the smaller cannot go into the larger, you're going to have to change both fractions to equivalent fractions with the same denominator. Ideally, finding the smallest common denominator, the least common denominator, is the same as the least common multiple of the two denominators, and that is best. So we have to review what the least common multiple is. Least common multiple is the smallest multiple that two or more numbers have in common. Multiples are the results or product of multiplication. We can always make a list. I could say 24 times 1 gives me 24. 24 times 2 gives me 48. 24 times 3 gives me 72. 24 times 4 gives me 96, and so forth. These are all called multiples, multiples of 24. Then I could go down further and I can find multiples of 36. Well, 36 times 1 is 36. 36 times 2 is 72. 36 times 3 is 108, and so forth. Well, I'm looking for the smallest multiple these two numbers have in common. They both have a 72 in common. So 72 is going to be the least common multiple. And if we're dealing with fractions, we call that the least common denominator. Another way to find the least common multiple is to make a factor table, a prime factor table. I find all the prime factors of 24, all the prime factors of 36, and then I can just simply bring each one down. And multiply them all across to get my 72. That's one way. Also, with the factor table, I could take the 24 times the value that is missing. And in this case, it's a 3. 24 times 3 is going to give me 72. Or I could take the 36 times the value that it's missing. Which is a 2. 36 times 2 is 72. Either way, I both get my 72, which is the least common multiple of 24 and 36. So if I had a fraction of 1 over 24 plus 5 over 26, and I had to make those fractions equivalent fractions with a denominator of 72, I had to multiply the denominator by a number that will equal 72. Well, I know that 24 times 3 will give me 72. So that's why I multiplied the first fraction by 3, the top and the bottom, which ends up being 3 over 72. My 5 over 36, well, I know I had to multiply 36 by 2 to get 72. So I had to do that to the numerator and denominator, which gives me a 10 over 72. Now that they have like denominators, I can add the numerators, the top. 3 plus 10 is going to give me 13. Now 13 and 72 don't have any common factors, so I can't reduce it. You always want to double check to see if there's anything that can go into the numerator and denominator. Always put your fractions in reduced form, unless told not to. So, as a recap, adding fractions that have different denominators. Determine the least common denominator, either by a listing method, always check to see if the smaller one goes into the larger, or you could do a prime factor table. Then create equivalent fractions that have the least common denominator for each fraction. Add or subtract the numerators, and then lastly, reduce if possible. So 28 divided by 14. So in this very first problem, I have 5 over 14 minus 3 over 28. I'm going to check to see if the smaller number, smaller denominator, goes into the larger denominator, and it does. 28 is divisible by 14. It gives me 2. So therefore, I can change that first fraction as an equivalent fraction by simply multiplying the numerator and denominator by 2. Because 14 times 2 will give me 28. The 3 over 28 doesn't need to change. It just stays the same. So now I have two fractions that have the same denominator. I can subtract my numerators, and I get 7 over 28. Now 7 over 28 can reduce because 7 can go into 7 and 7 can go into 28. So I'm going to divide my numerator and denominator by the common factor of 7 to get 1/4. Let's go on to the next problem. -4/50 minus 3/18. Now 18 can't go into 50, so 50 cannot be the least common denominator. So I'm going to have to determine my least common denominator. I could do a factor tree, prime tables. I could do a list method. As you see it down below here, I did the prime factors. I found the prime factors of 50 and, oh, here they are, of 50, and the prime factors of 18. So if they have something in common, I only bring it down once. Since they both have a 2, I only put the 2 one time. Now they don't both have 5, so both 5s have to come down. And they both don't have 3s, so both 3's have to come down. Then I multiply all 1, 2, 3, 4, 5 of those numbers to get 450. Now, to determine what I needed to multiply to 50 to get 450, I looked to see what was missing. Well, I have the 2, and I have 2 5s, but I didn't have the 3's. So the 3's had to be multiplied to the numerator and denominator of the fraction that had 50 as its denominator. Now I have to go over and figure out what I had to multiply to 18. So 18 is missing the 5's. So I'm going to have to multiply both 5's to the numerator and denominator of that fraction. So I end up with negative 36 over 450 minus 75 over 450. I'm going to rewrite that as an addition problem over the common denominator. So negative 36 plus a negative 75. The rules of integers say if they're the same sign, I just add them and I get more negatives. Negative 111 over 450. Now both of those are divisible by 3. The divisibility rules tell me if I add my digits, 1 plus 1 plus 1 is 3, 3 can go into 3, and 4 plus 5 plus 0 is 9, 3 can go into 9, 3 can go into the larger number. So I know that 3 can go into both of those. So I divide the numerator and denominator by 3, and I get negative 37 over 150. Now neither one of those have a common factor. Let's move on. So stop the video and complete the problems, and then check your work to see how you did. So how did you do? Negative 11 over 54 plus 7 ninths equals 31 54ths. Negative 1 over 24 minus 5 14ths is equal to negative 67 over 168. 5 twelfths plus 8 33 or 8 33rds is equivalent to, or the sum equals 29 over 44. We are now to our discussion board problems. Go ahead and write down 3 problems on paper, complete them, scan or take a photo image, and then upload to the appropriate discussion board form. Be sure to show all your steps